Yeah, actually transport layer when it got a when it got the data from the upper layer, that is whatever the service is giving the data to him. Okay, it will check whether this much amount of data can be sent out or not. Okay, see, data whatever the data is generated by the process, it cannot all be sent at a time. It might at sometimes it might be sending it might be giving it around 500 MB of data. Okay, and at sometimes it might be giving it 1000 MB of data. Okay, but actually once whatever the data it got, but actually what happens is transport layer will check what is my MSS. MSS in the sense maximum segment size. Okay, maximum segment size. MSS is calculated. Write this formula. It's very important. MTU minus transport layer header plus network layer header. You got it? Transport layer, whatever the data it got from the upper layer or whatever the services, whatever the data it is given by the whatever the protocol, it will check what is my MSS. Okay, what is my MSS, which in an MSS equal to MTU, maximum transmission unit. Maximum transmission unit. MTU. MTU minus transport layer header plus network layer header. Okay, I'll explain you, but write the formula. You wrote it? You wrote it? Right. Yes. Now, what happens? So, what actually happens is when the data is sent by the application layer, all the process is done, and the router or the device, whatever the device is there. For suppose think that this is my PC. My PC has some interface to the wired connection. Yes, it has some interface, that is RJ45. Okay, now my device will check for 1 second how much amount of data can I send through my interface. Got it? It depends on the type of port you are using. If you are using Ethernet port, it will be little low, and if you are using fast Ethernet port, it will be according to the range of the port you are using. Okay, but on an app, always we consider it as 1500 bytes. Always we consider it as 1500 bytes. Okay, by default for the devices, whatever the devices we are using in present scenario in today's technology, it has a interface MTU as 1500 bytes. Done. So this is my MTU by default, but this can be changed. This can be changed. My MTU is 1500 bytes. Now MSS is calculated. You know what is MTU, right? Per second, what is the amount of data I can send through my interface? If a packet is received above size more than this MTU, it will be dropped at this level. Okay, first point. And now my process will calculate my MSS, which is 1500 is my MTU minus my transport layer header, which will be of 20 bytes, and network layer header, which will be of 20 bytes again by default. So now 1500 minus 40, 1460 bytes. Got it? Yes. So what it does, when a transport layer, when it gets a packet from the upper, when it gets the data from the upper layer, it will check its MSS. By default, it is 1460. Okay. Now, for suppose think that this is my 1460 bytes. Now I got around 50 MB. Now this process transport layer will divide that huge amount into multiples of 1460 bytes. Got it? It is very simple. Dividing the huge amount of data into small things, which can go through the interface. Okay, done. So this process is called segmentation. You got what is segmentation, right? So transport layer itself will do the segmentation. Okay. Now segmentation is done. I mean the data is divided, but the receiving device, it has to reassemble them. Okay, it has to reassemble them because that huge amount of data is divided into small chunks. Now it has to reassemble them and it has to give it to the process. In order to reassemble it, in order to make that work easy, we do sequencing and reassembly. Where in sequencing we assign numbers, serial numbers. For suppose 1, 2, 3, 4, 5. The device whichever it receives, it will again reassemble them in the order 1, 2, 3, 4. Okay. Segmentation is done. Sequencing and reassembling. Okay. Windowing, buffering, and congestion avoidance. These are for the flow control. Okay, flow control. See, transport in the transport layer, if you are using TCP, I'm sending you the data. As a TCP is a reliable protocol, what it is, it will make sure that whatever the data I send, it must be received by you. Okay. In this case, okay, in this case, you are capable of processing 10 packets per second. Now what I'm doing, I'm sending 100 packets per you. What will you do? You will process the 10 packets, but remaining 90 packets will be dropped. In order to avoid this situation, what will happen by doing this? First thing is packet will be dropped. Second thing is congestion. For suppose think that you thought that okay, I will save these packets and I'll slowly process them. What will happen? The traffic will be congested. Now the 90 packets will be saved, but within next second, I send you next 100 packets. The packet will be congested. The data will be congested, right? To avoid this situation, to make the packet, to make the data flow easily, to make it go in a particular way, we use flow control. That is flow control to avoid this situation. Okay, how do we avoid it? Using these three cases. One is windowing, buffering, and congestion avoidance. Okay, windowing is if when the connection is established, Okay, when three-way handshake is done, first itself, I will tell you this is my Windows size. Okay, you have to just send me this much amount of data and stop. Okay, for suppose things that you are capable of solving or processing 10 packets. You will tell me your Windows size and my windowing size is this much. According to the 10 packets, you will calculate the size for 10 packets. What will be the size of the each packet into 10, and whatever the size you got, you will send. Now, what will I do? I will send only that amount of data. By this, what happened? The packet drop will be released, will not be done. Processing will be easier for you. Congestion will be avoided, right? And doing this, that will be avoided. And what is buffering? For suppose we'll take the same scenario. You are able to process the same 10 packets, okay? But I'm sending 20 packets. Instead of dropping the packets, what will you do is you will keep a separate memory for it, buffer memory. When I send you the 20 packets, you will solve the 10 packets, and the remaining 10 packets will be saved in the buffer, and you will tell me the acknowledgement that I got 20 packets. Instead of wasting the time or dropping the packets, you by doing buffering, flow will be easy. And congestion avoidance is already I told you using window size. You send me that window size. Instead of me, I am sending that many packets. What will I do? Whatever the thing you can solve, I will send you. This is windowing, buffering, and condition avoidance. These comes under flow. Error correction is done at the transport layer. Error correction is done at the transport layer. How? See, for suppose I send you 1, 2, 3, 4, 5 packets. Okay, but you the receiver got only 1, 2, and 5. You lost 3 and 4. You didn't receive it. It is an error. How it will be corrected? You will tell me an acknowledgement that I got 1 and 2, but I didn't receive 3. Send me 3. Seeing this message, I will come to know, yeah, some error was there. The receiver has not received 3 and 4 packets. Then I will send again back 3 and 4. So all these collectively, the acknowledgements, windowing, buffering, congestion avoidance, all these works collectively, and the process will be made easier and reliable. And the same thing, if you are considering the examples in the transport area, you'll be having TCP and okay.